Hey there folks. So in this video we're going to be looking at two nodes. We're going to be looking at the create points node and the copy points node. And the purpose for this is to create what you can kind of see here. We've got a grid of points that have been created around the location of another point. And then we can obviously use those to spawn smaller objects or scatter objects around something else. So here I'm going to go through two examples. The first one is going to be using our surface sampler. So you can see here I've got these large cubes that are kind of already placed in, and I'm going to create grid references, grid points all around those that we can then use. And then I'm going to go through another one that builds off of what we've previously looked at, which is the actor data stuff. So if I just show you this, if I was to turn that one off and change it to be this one instead, I'm going to use the actual positional data of other blueprint actors, other elements that we can bring into our PCG in order to scatter points around them. So for example, like this building here, what if I wanted to put some points around that I could use for, I don't know, spawning some objects that the people who live in these buildings might need, or just random debris and objects around that. Now there's a few applications of this. I'm just going to jump over here for a moment. Things like rocks and plants and trees and things like that are going to get a lot of use out of this one. So here what I've done is I've used a very large rock. So anywhere you can see these large rocks, these are my main points. And then what I'm doing is I'm creating a points grid around those to scatter the smaller medium rocks. And then around those, I'm scattering another grid of these kind of smaller objects and the grass tufts and things as well. It's not the greatest, but it can obviously show you how we can get that one big rock, and then pieces that over time are eroded and fall off and break apart from this will obviously form around this. And I can try and maybe pull the grid sizes and pull them together a little bit. I've also got this example here, which is using a spline. We'll look at splines in a future video, but it's using splines to create some points, and inside of those points, wherever the grass is, it's then throwing out smaller little tufts of grass around that. And it's trying to emulate what would happen with elements like trees and plants and grass, where the main one's going to end up pollinating and spreading seeds to smaller kind of areas around it, and then they'll grow, and bit by bit that grass or that plantage will grow as well. So lots and lots of uses for this. So let's get into how it actually works. Okay, so I'm here now and I'm looking at this space where I'm going to put my PCG, and I've created a blank PCG volume to test this out. It's called create copy points. That's what we're going to be doing. We're going to be creating some points and then copying them onto something else. So let's start by first of all having a look at creating points. I'm going to just type in and look for create, and you'll see there's a whole bunch of different options we've got, and the one we want for this is create points grid. You'll notice it says there it can be a 2D or a 3D grid of points. So if we have the actual size of the points lower than the Z value that's being assigned, we can create a flat 2D grid, but we could also increase that size to a much higher Z value, and then we can create rows and columns and the depth and height of this to create a kind of volume of points as well. So it's a very powerful node. I'm going to just add this in, and I'm just going to debug it, and you'll see that I can't see anything in this space here. But if I were to inspect it by pressing A, and I've got this PCG element here selected, you'll see that there are a whole bunch of points, but they're all defaulting here over to closer to my 0, 0, 0, my world origin. So where is that? Well, over here underneath this forest, you'll see that's where they're all appearing. Now I would leave them there, and that's where they're going to have to be in terms of their position in a moment when we start copying them onto stuff. But for now, I'm just going to go into this coordinate space option and change it from global to original component, just so when I'm working on this this create points grid, I can see actually what's happening. And then once we've finished getting them to the sizing and the spacing that we want, then we'll change it back to the global option. Okay, so the first option we're going to look at is this grid extents, and the grid extents is going to tell us how far this is going to reach. Now you see it's an XYZ, it's a vector, and right now it's 500 by 500 by 50. Well, it's actually not fully 500. If we were to look at these points here, and actually it might be just a little bit easier for a moment to look at them as global, you can see it's going from this minus value all the way up to positive value. So I've got a 450 there, and I've got a minus 450. So actually what's going on here is we're creating a grid from around a central point, around a central location, and it's going 500 one direction and the other direction, this direction and this direction as well. So what we're actually getting is a grid of 1000. It's worth just noting that this grid extent is going to actually be double the size when it comes to the actual grid size that we create here. So let's just see what happens when I resize this. If I go from 500 to 800, you can see that that obviously gets much, much larger. I can go to much, much smaller as well. So let's go to 100. And again, I've gone down to a much smaller size. I'm going to go back to 800 just for a moment. And you can see that if I actually go with the Z value here, so 50, let's just put that at 500. You can see that it is creating points vertically up as well. Now, they're not very visible. All those points I've just created, at no point could you really discern whether that was creating one big point for me of that size or whether it was creating lots of points. Now, I could put a noise modifier or something onto here to see this, but what I'm going to do, just to make it easier for you guys to notice what's actually happening, is I'm going to add on a bounds modifier. And the bounds modifier, by leaving it as scale, I'm going to multiply and scale the bounds. So if we look here where I'm inspecting and just go along, I'm going to take these -50 and 50 bounds value and multiply it by this min and max multiplier here. Now 1, if you multiply something by 1, it's going to stay as what it is. So let's just put it as something like 0.9. Actually, let's go 0.8. Give ourselves a little bit of visual spacing. If I put that onto every single one of these, I'm not going to see any difference yet because I've got to debug this node instead of this one. But now you can see where each of those individual points is being created. And as I said, I've moved the Z value up to 500. You can see there's a whole grid of them. And this could be really useful for building buildings. You know, I could have a wall. I could find all the ones that are on the edges and use those for walls or floors or ceilings, or I could use them for creating things on the interior of the volume. Okay, so let's go back to here and let's change that from 500 back down to 50. And I've got this flat grid of points that I can use. The next thing I'm going to look at is this cell size. And this is where it's useful to think of this as actually being a grid. If you were thinking of like a grid as like an Excel spreadsheet, now we've got a table, and each of those squares, each of those points inside of that table is a cell. So here we're saying that the cell size is 100. Well, that means that for 800, each one of the actual cells, the grid elements that are inside of there, is only 100 in size. And each of these points basically fills a cell. So here I'm actually saying that I have got 8 points. Well, we know we've just said it's double the size. So actually what I'm creating here is 16 points. So this is a 16 by 16 grid. We can think about this, you know, if we change these values around, let's go with 400. And you'd think now, well, I've actually got 2 because I'm fitting 2 of them in this 800 and then double it because of the width. So we go, and let's just make sure that's actually 400. There we go. And now you can see that in this 800 section, I've got 2 of them, each of them 400. And if I was to inspect on this node, you can see that they were at their value of 200 by 200, because obviously they need to fit in a 400. So their bounds would be -200 and +200. So they could fit in a size of 400. But because they're being multiplied by 0.8, they've changed to -160 to 160. Okay, so you can see that messing around with that is going to give us the control over how many points we've got. If we want to look at the spacing and things like that, we're going to have to do other manipulations afterwards. But for now, this is going to give me a kind of an indication of how big my points are going to be and how many they're going to be. So let's go with maybe something like, let's go 200 by 200. And I think that's fine because I think we've got a nice group of points there. Yeah, there we go. That's going to work nicely for us. And not too many, just so that we can actually visualize what's going on. Okay, so that's creating our points grid, and that's manipulating their size. Next, what we're going to look at is how we can get these points that we've just created and get them to spawn at the location of something else. Yeah, because they're great as they are, we can kind of define just this grid and have a grid that just appears in the middle of a volume. But how is this useful? Really, we need some other points values, and we need to be able to start saying wherever those other points values are, let's create a grid like this around it. So to do this next bit, what I'm just going to do just for a moment is I'm just going to turn off the debugging and inspecting of this create points grid and bounds modifier. And I'm just going to work on some stuff that we already should be really familiar with. I'm just going to create some points on our landscape that we can actually use for spawning the grids around. So I'm going to start by getting landscape data, and there's not really anything I need to change or worry about here. So I'm just going to go off of that and create myself a surface sampler. I debug that, you can see obviously it's creating a lot of points, and if every single one of these points here was to create a points grid around it with so many points that we already have, then what we're going to find is this is just going to be really, really busy and there's lots of stuff going on. So let's just increase the actual size of these points a little bit. They would represent the big important points that we have. And I'm also just going to increase some of this looseness just so I can spread them around a little bit. And that'll work just for now. I can always decrease the amount of them that there are. Here you can see obviously they're at the limit of what they can be. But if I was to, spread these around or change the points, then that points per square meter would kick in. Okay, so I've got this, and what I'm probably going to do at this point now is just do a named reroute declaration, just because rather than having lots of things going across and plugging into each other, it's kind of just easier to save these points as they are, and then I can reuse them somewhere else. So let's go with this as a large sampled points, and that's going to give me something that I can use up here when I'm working on my create grid. So let's actually use that. Let's test this out and see what's going on. Now, I want to take these points that exist here, these create points grid points that I've created, and I want to copy them so that they appear around these points here, these large sampled points. Now, to do that, we're going to look for a node called copy points. So you can see here it exists inside of the sampler section. And what it's looking for is it's saying, what are the points that I want to source, the points that I'm actually going to be spreading around, and what is the target? What are the things that I'm going to add these to? Now you can see you can just plug that in there and that would be fine. But just to keep it nice and organized, you never know how these things here might move around and extend out. To avoid having lots and lots of kind of overlapping lines, the name reroute comes in useful because I can just type in here large sampled points and I can just apply it into there. Now, bunch of stuff you can do with this copy points. We're not going to really mess around with them just too much here for this demo, but you can choose where they're inheriting their information from. So if you've used transform modifiers, transform points things along the way in either of these paths, you can choose to, inherit the rotation, the scale, the color, maybe the seed value, the attributes. You can choose to be getting it from the source first or from the target first, or one or the other only. So there's a lot of choices we can have here where we can take just information from one place, whether it's this path down here or this path here. Now, if I was to debug on this copy points, you're not actually going to see anything going on here. Yeah, and it's a weird one where you can't actually just debug the copy points to see what the outcome of these combinations are. What you kind of need to do is add another step afterwards in order to see this. So you could just add yourself in a 2-point kind of conversion, and then you'd be able to at least say take this data, convert it to a point and debug. Or we could add ourselves in another noise volume or a noise node just to see what's going on. So I am going to just add in an attribute noise, and if I add this in and change it from, rather than last, let's change it to be density into source, set it to 0 to 1, I should be able to press D and see all this happening. Now there's a reason why it's not showing up. And that's because right now this create points grid is not using the actual coordinate space that we need. It needs to be using the global coordinate space to be able to actually appear. So I said that earlier on, we moved it from global into original component so we could see it for debugging. But now I put this on and you can see all of these points being created around each of those larger points. So I'm debugging to see the larger points, and then I've obviously got a little grid of them going around each one. Now you can see this, you can obviously go back and debug it. You can change the cell size. So if you're thinking that maybe these are much too large, you could increase the cell size to have less of them. You could decrease the cell size to have more of them. You could increase this scale modifier in the bounds. So here I'm saying 0.8 as my actual scalar. If I went down to like 0.5, then I would be halving the size of these, and I could obviously increase the distance between each one of them, spread them out a little bit. We have looked at other methods for obviously filtering out information as well. So now, because I've put noise onto all these, I could look at a density filter to remove some of them. And you could also look at things like self-pruning, and you could use this as a method to look where there are overlaps. So you can see here I'm reducing down based on the overlaps that we have, or even the small to large. So there's lots of options, lots of things that we can do. And that's a really quick and easy way of putting a whole spread of points all the way around other existing points using the position of things like trees, a fallen log, a tree stump, rocks, and using it to spawn smaller elements around there. It's going to match what we have in nature in terms of large plants spreading smaller flowers and smaller plants around them. It's going to match what we have in terms of rocks and large rocks being surrounded by medium, then smaller rocks. Over time, they obviously erode, break apart, break down, and that's going to create something that's a bit more realistic for us. Okay, so there's one more last thing to do, and that's to look at how we can use these buildings here, these actual kind of blueprint buildings that I've created, and use these as the origin rather than as sample points. So let's look how we can actually do that. Okay, so to get ready for the blueprint bit, I've just made a couple of edits here. I've just stopped debugging the landscape sampling, and obviously by disconnecting that, you can see now we can't see anything from any of these debugs over here because we don't have a target anymore. These nodes are telling me that there's nothing plugged into them, so they know that they're not working. And I've just dragged these buildings in over here. And the key thing with these buildings, so I'll just show you this just for a moment. The key thing with these buildings is that each one of them has a tag, and you can see actually there's multiple tags on here. There's the PCG exclude tag, which is being used from previous demos, so that I could take this building and I can put it into other PCG areas and see that it updates and removes things. And I've also added another tag here called PCG building. If I was to go into each of these buildings and maybe just have a look at them as an actual kind of as an actor. So let's just go in here. I can go to the PCG buildings and type in tag, and you can see I've added in PCG building as a tag. It doesn't really matter what this tag is. I've just used this one as a little bit of a demo for the purposes of what this is. These are PCG buildings. I'm just defining them as PCG building. You can use whatever tag you want, you know, large rocks, small rocks, whatever it needs to be. So let's just follow the exact same process that we've used before when it comes to actually putting together some kind of actor data for this. We're going to start by getting actor data, and this is going to be the thing that's going to look for something or things in our world. Now right now you can see it's saying self, so it's looking at what's contained already inside of this PCG volume. There is nothing here that's going to have that tag, so rather than searching self, we want to search for the all world actors. And then we want to search as default by tag and search for our PCG buildings. Not actually that one. That's not the one I want. I want this PCG building tag here. Okay, there we go. So now you can see it tells me what tag it's specifically looking for. And a couple other things that we might need to do. The first one is select multiple, because if I look here, I've got 3 of these. I want each one of them to be spawning points around them. So I'm going to need to make sure that this is actually going to take into account all 3. I'm going to also need to make sure that I have this must overlap self on here as well. So this is just going to make sure that it only does these ones if they're inside of this volume. Now there is another little bug potentially for us to fix here, which you might see. This create points grid. Notice that it's got cull points outside of volume. If you're finding that none of your points are actually spawning, just check turning this on and off. Sometimes it tries to create a points grid and one of those points is too near the edge of the volume, and then it just doesn't spawn any of them, because obviously this isn't taking into account the spawning of all of the points for all of the grids individually. It's just saying if any of these points are outside of the volume, then they're going to get culled. So just be careful of that. If you do find that all of your points aren't showing up, just try turning that off. Okay, so back to our get actor data. I've found all the world actors that have this tag. I've searched for PCG building, and the next thing I'm going to do is I'm just going to add myself an extents modifier here. Now you can see it's just doing a bit of a conversion for me, and that's because this doesn't actually know what type of data it is. So you can see here, when we're looking at this mode, this data retrieval mode, we're passing actor components. So we're looking for relevant components, things like primitives, splines, and volumes. We're not actually getting ourselves any point information. So a useful thing you can actually do with get actor data here, rather than having to do this conversion, is you can say, I would like to, instead of doing this, just get a single point. So I can say wherever this thing is, I want to get its location as a single point, which is really useful for what we're doing here with this create points grid, because we just need to know individual set points for that. So if I was to use it as is, I'd probably be fine. But let's just look at what happens if we do add in that extents modifier in a moment. So I'm going to just add in myself another named reroute declaration node, and I'm going to call this one building actor. I'm just go lock or points, and see what happens if we plug that in as our location. Okay, so I'm just going to plug that into there, and I'm just going to go and see what that looks like in the level. Okay, so we're back in the level now, and what you can see is that this get actor data is finding the blueprints with the tag PCG building. It's saving it into a name reroute for me, and then it's using that as the target for us to copy a points grid on. And for each one of these buildings, it has created a points grid. If I was to duplicate a building and drag a new one out, you can see that I can obviously create another grid, and those grids are obviously being arranged and orientated around these objects. So you can see how just placing these things out is going to give you a lot of control of where you can scatter objects around. Okay, so let's see if we can just take this a little bit further. So we've got a version of it that uses the landscape data, and you can see I could just swap it from one to the other. If I just debug here, you can see I've got the sampler version where it's taking the landscape and sampling it, or I've got the actor version. Let's look at how we can add some extra controls and options into here just to make this just a little bit more interesting. The first one is this get actor data. If I debug this just to see the point, it's creating one point, and it's creating a point where the bounds, the actual size of it, is determined by that collision that exists all the way around. Now, you might not want to have that, and the bigger these buildings get, obviously that's going to also stretch things out and change that. So here, what I might recommend that you do is, rather than just using the actual bounds of this for things like difference nodes, I might take this and I might plug it into an extents modifier. And if I leave that extents modifier as a set, what's going to happen is, instead of actually kind of, just turn off the debug for this one and debug there, instead of actually setting it to whatever the size of the collision of the object is, it's going to set it to whatever the extents says it should be. And right now you can see there's a tiny little cube in there, 1, 1, 1. Well, let's change that, and rather than having it as 1, 1, 1, let's make this just that little bit bigger. I find with this one, somewhere around about 300 by 300 by maybe 300 or 400 might actually work here. Just make sure it goes through the floor. Now, I know that feels like it's very close to what we already had, but the key thing here is that the extents modifier gives us the control. If we want to push these cubes a little bit, these points a little bit closer to the wall, well, we can just say that maybe this isn't as big as it actually is. Maybe we can pull that one back in. We can even go even further. Yeah, we can go all the way to 200. So we've got the control with the extents modifier node now to define how big the point is that this get actor data is containing. We're overriding the point value. I've made sure that it's a little bit taller here because it's appearing and making its point happen directly in the middle of the blueprint actor. And so what I've done is I've just made it much taller, so I know that it's going to collide through into the floor, around by the floor, so I can get the position of it and use it to remove any that are on the floor around it. Okay, so let's just jump along here. I'm going to use this attribute noise. You can see I could take that attribute noise and I could use a density filter to remove some of the points from there. What I might do is I might add in a transform points node, and couple of things that we might want to do here. So you can see when I'm at the attribute noise, look how organized and tidy each one of those points are. And that's because each one of them has its own cell that it exists in inside of the grid. Well, we could just take this 360 degree and rotate it. So let's just see what it looks like now. A bit more interesting. They're not so uniform in their layout. We could obviously rotate the minimum max values if we really wanted to, but I'm going to go up to this offset, and I might want to move it up a little bit, but the real beauty of this is going to be the X and the Y. This is what's going to break up our grid pattern. Now, this is going to be dependent on the amount of points that you've got and the size and spacing of them. But something like going, okay, well, what about if I move them anywhere from between -75 to 75 on this axis? You can see now they're all moving around. And if I go with same on the Y value, so -75 and 75, you can see how they've all been pushed around. Some of them are bunched up together, some of them have been spread out, and all of this has become a little bit less uniform. We can take that further by adding some scaling in. So I'm going to go between 0.7 and 1.3. And then you can see all of these objects, all these points or potential places where I can spawn objects are much, much different in their kind of sizing and spacing and a bit more realistic. I can use this for rocks, grass, plants, and things like that. Okay, so what else might I want to do? Well, after that, I might want to use self-pruning to get rid of any of the overlaps. So you can see here, I can use that to kind of look for any clusters of overlaps, and that removes some of that for me. I can still have the density, so I can use the density at any point to go, I want to have plants on a certain value and I want to have flowers on a certain value. What the last thing I might do is I might just use a difference node, and we've already saved things like, you know, the building actor location, the large sample points. So let's come in here and use the building actor location, and we'll use that in the difference node to remove it. Now we're not going to see this immediately. If I go in here and stop debugging that, you'll see that these points are still appearing inside. Just remember, difference nodes, to get rid of the stuff, we need to just use the binary, and that should remove these elements from there. So I'm just going to debug there, and they're all gone. Okay, so now that means that I can place in as many buildings as I want, and around each one of those buildings, I can use this to scatter other points. Every time I move these buildings around, wherever they are is where I'm going to get points. And because this all exists in this one singular kind of path of points, it means if I have lots of them all placed next to each other, they should start filtering against each other as well. So you can see, probably need to do a little bit of combining here, just because when I put this one and this one over each other, they actually don't fully remove from each other. So what we could do here is maybe look at a union node, and now we've made all of these points the same path, and that should have joined them all together. Let's just check that out. If I bring this building in, yeah, there we go. So I've combined each of these point grids using that union node to say that they are all now read as one piece of information. That's what's going on here. It's converting that data into point data for me, and then all the rest of that gets applied. So this grid, and this grid, they're all now combined essentially, as far as it's kind of looking at all these information rather than individual create points grids. It's combined them all into one, and then the attribute noise, transform points, self pruning, and difference is all being combined. So I can do a whole bunch of really awesome stuff now by moving them all next to each other, and you can see there they all blend together. No overlaps, no really awkward sizing. Okay, so really perfect, really useful kind of thing that we can build there. As we've mentioned right at the start, we could use this for scattering smaller objects around, like rocks around large rocks. We could use it for the spreading out of foliage. I might want to use it on like the edge of a forest. So rather than a forest kind of just getting to the edge and kind of ending at this point, what we might want to do is we might want to say, let's find a few key points that we use for the main trees, and then scatter trees and smaller trees around that. And then we can have a much more natural spread of forest. We could use it for, you know, these flowers, rather than just randomly throwing the flowers out. We could use it to create a point where one main flower is going to be, and then scatter out smaller versions of it where it's kind of spread with wings and pollination to create a more realistic and natural representation of it. Thanks for watching, folks. If you enjoyed this video, then please consider subscribing to access more of my Unreal Engine content.